Why hasn't anybody taught me discontinuities this way? Okay, so the function we're given is f of x equals floor x, and we're told to identify the types of discontinuity and where the function is discontinuous. So the idea of a floor function is very simple. It's kind of like rounding. If you remember rounding, it's kind of like that, but instead of rounding it up or down depending on your decimal, it always rounds down. What do I mean by that? Well, if I take floor of 2, that outputs just a value of 2, but if I have a value of floor 2.1, then that would give me a value of 2. And it doesn't change directions if I get bigger than 5. So if I had floor of 2.77, that still equals 2. And so it's not about rounding, but it's just about bringing the decimal down to its whole number part. So now that we know a little bit about floor functions, we have to try to figure out where the discontinuity is. Well, here's the thing. A floor function can take any value of x, positive or negative. So really, x can be all real numbers. But what we want to look for is where does it jump? So we're going to have to use limits. Now, it doesn't really matter what the limit goes to, so let's just say limit as x approaches 1. But we're going to take the left-handed limit of that, and we're also going to take the right-handed limit as x approaches 1. So for our left-handed limit, I'm going to make a little table, and we're going to say x and f of x, and we're going to pick progressively closer increments of x. So we're going to use these values of x, and basically we need to just plug it into our floor function. Okay, so it's pretty clear, as x approaches 1 from the left, our limit is 0. Now let's do that same thing, but from the right. Okay, so we're going to use these values of x. Now, the only difference is that this side is greater than 1, not less than 1 like we see over here. Okay, so we clearly see a discontinuity here, but there's one more problem. Remember what I said, x can be all real numbers. So this also applies from 1 to 2, 2 to 3, 3 to 4, so on and so on. And it also applies in the negative direction, 0 to negative 1, negative 1 to negative 2, negative 2 to negative 3, and so on and so on and so on. Now it's not just for 0 and 1, it is for all integers of x. So we can plug in all real numbers for x, but the type of discontinuity is a jump discontinuity, getting different answers for the same input, and it happens where x equals all integers. This problem was definitely a little trickier, but I would love to hear what you guys have to say down below.